In this next video tutorial, what we're going to do is go back to that original survey data. Now that we've got whatever raster you end up using, I'm just using my 1 meter raster, but you'll decide what resolution is the most appropriate. I'll stick with that 1 meter, and I'm going to go back to my original survey data. What I'm going to do is I'm going to look at that attribute table and remind myself that I've got these edge of water shots. I've got right edge of water and left edge of water, so REW and LEW. Okay, and so I can do a select by attributes, and I can create a new selection, and I will go to my code, and I'm going to say where code is equal to, I'm going to get the unique values, left edge of water, or where code is equal to right edge of water. I hit apply, and now if I switch to show selected records, now I've got the 926 of the 5,638 points, which actually represent my water. Okay, so if I were to zoom into here, I would see that those are just the water edge shots. So what I'm going to do is I'm going to take those points and I'm going to export data, and I'm just going to take the selected features as opposed to all the features, and I'm going to put those into this geodatabase at the same place where the total survey points are right now, but I'm going to call those water edge points. Okay, go ahead and click OK, and asks if I want to add that to the layer. Yes, or add it to my map. Yes, I do. And if I clear my selected features and turn off that stuff underneath, now I can see I've got these water edge points. Okay, so what we're going to do is turn on our water limits as well, and you can see that someone, the good thing for you is that someone wasn't you, went through and connected all the dots in a tedious editing exercise. So to save you a little bit of time, I've provided you that layer. It's called water limits. And now we're going to make a tin out of those water edge points and using that water limits as our hard clip polygon. So you already know how to do this. We're going to go to 3D Analyst Tools in our toolbox. We're going to go to Tin Management, Create Tin. We're going to specify our output tin. In this case, we'll call it our WS water surface tin. Okay, and we'll import the spatial reference from any of the other guys. And we're going to use water edge points, and those will be our mass points. And then we'll use our water limits. And what we need to make sure is that we change that height field to none, and that we do that as a hard clip polygon. Go ahead and click OK, and this will quite quickly produce a water surface tin. I can't see it because it's underneath those other layers, but now I can see this tin and the elevations going from the top of the reach where it's higher all the way down to the bottom of the reach. And you'll notice too that there are these pretty abrupt steps in the water surface topography, and that is right, because in this reach we end up having a bunch of beaver dams that are creating those steps in the water surface topography. So what I can do is I don't see any, if I kind of pan in and zoom through here, I don't see anything that looks terribly unreasonable. Any real major busts in that. There's a little bit of stuff going on here and there. Some of that is probably a little bit of a misrepresentation, but for now we're going to live with that and call that a decent water surface model. And so we will do our conversion from tin to raster like we did in the last video tutorial. We'll convert our water surface tin, and we'll put it in our geodatabase, and we'll call this water surface 100 centimeter. Okay. Again, we'll do it as float and natural neighbors for the method. And then the cell size, again, better be 1.00. And now we're going to do something we haven't done before, and we're going to be very careful that we have the exact same raster extents as our DEM. So we're going to go in the Environments tab, and we're going to go to this Processing Extent. And instead of just using the default, what we're going to use is same as layer DEM 100. So now it's going to use the exact same top, left, bottom, and right hand coordinates for that bounding grid. And we'll go ahead and click OK on that, and OK, and that's going to force these to make concurrent rasters out of the two. Okay, it's gone ahead and it's created that water surface, and so here we can see it now. And so while the water surface is it's helpful for getting a feel for the slope through the reach, what we'd really like to be able to look at is water depth. And so the next thing that we're going to do is we're going to go into the Spatial Analyst tools, and we're going to go to Map Algebra and to the raster calculator, and we're going to take the higher water surface and we're going to subtract from it the lower DEM values, and we're going to put that calculation in here, and we'll call that WD 100 centimeters try 1, and you'll see why in a second. Okay, so it's finished that calculation, and if I turn off this and if I change this calculation, well, actually the first thing to notice here, so dark is going to be shallow or unrealistic, and light is going to be deeper water in this case. So the reason we call this try 1, you'll notice that there's some positive values, okay, and those positive values are not I'm sorry, there's negative values. The positive values are real. Those are going to be water depth values. The negative values are areas where the water surface was lower than the actual DEM. And so those are areas where water should be dry. You could visualize or think about those if you believe the water surface topography as groundwater. But we just want a water depth map of surface water here. So we want to get rid of those areas. So how are we going to do that? So what we're going to use to get rid of those negative values is a sequence of raster calculator and reclassification steps. So we'll first find out everywhere where our water depth map is greater than or equal to 0. Okay, and I'm just going to let this save this as raster 2, just because this is an intermediate garbage raster. So that returns for everywhere where there is data, that will return a 1 or a 0. Okay, and so we should see this nice categorical raster. So basically, in here, everywhere where there's a 0 is a place where that logic was false. Okay, so it's those areas that we want to get rid of in the water depth map. So to get rid of them, we're going to use a reclassification, and we're going to reclassify that raster 2, where the old value of 0 becomes no data, and then 1 will just let that remain as a 1. Okay, and so our reclass raster will just let that be a raster 1. So now this comes in and if I compare these, now suddenly I can see those areas in the water depth raster underneath that had the negative values. So this one happens to be a beaver dam, same with that. These are some areas on the edges where there's just some exposed bars, and so all of those areas are going to be taken out in our next step here, where we go back to the raster classification, and what I'm going to do is take that reclassification raster and I'm going to multiply that by the water depth. And so I'll change the name this time to water depth 100 centimeters. And the reason this is going to work is because if in a raster calculator calculation, whenever I have a cell that has no data, i.e. these areas that we reclassified as no data, then whatever it gets multiplied by is also going to have no data. And so that's going to essentially act as a clip to clip us the water depth map down. Now all of the pink values are 1s, so I multiply 1 by the water depth and I'll get back the water depth that I'm after. So I click OK. And I get back a water depth map. If I turn off those intermediate layers. Now notice that it goes from a very small number, but it's a positive very small number, up to a high of 1.1 meters. So let's change this symbology. Let's change this to a classified. Or actually no, we can stick with stretched. But what we'll do is we will we'll set some custom settings here below. And so let's make our minimum, instead of that odd number, let's make it 0. And let's make our maximum 1.5 on the flow depth. Okay, and then we'll change this color ramp to something that looks like water. So light will be shallow and dark will be deep. And I'm going to change my label to 1.5 meters, and I'm going to change this to 0. Okay. And now I'm looking at a water depth map, and so I can see these deep areas, which in these cases happen to be behind beaver ponds, and I can see the lighter colored shallow areas. And I can also see that if I were to turn back on this, that I've clipped out those areas where I had water depth that were negative. Okay, and so that is how we get a water depth map. And you can notice that when I overlay that on the DEM, it does a very nice job of pulling out the morphology of the channel. This is something that is quite a useful visualization tool. So that concludes this video tutorial.